Carbon composite materials, which is a really strong plastic embedded with carbon fibers, is the best choice because not only does it keep its integrity when flying supersonically, it is even stronger than aluminum yet weighs half as much. Aluminum alloys are very lightweight and strong, which sounds perfect for the airframe of a plane. However, although its popular use after replacing a plane's wooden frame with this metal in the 1930s, aluminum strength tends to decrease when a plane, especially a supersonic one, creates friction with the air at high speeds, which is not an issue for carbon composite materials. Aluminum is sensitive to tension loads and not nearly as flexible as carbon composites. Another thing that is so special about these composites is its ability to absorb vibration so it can diminish the impact of collisions. As mentioned earlier, carbon composite materials offer the most strength with the least weight. Composite materials are specifically ideal for the wing skin because of its flexibility and has been growing in popularity since the mid-1970s. Although these carbon composite materials aren't exactly perfect, since when they do break, they don't show signs of breaking before failure. Either way, it is a much better option than steel, because steel is not only 70% heavier than composites, but it also attracts lightning strikes and corrodes easily. Examples of popular planes that use carbon composite materials in their wings are the Boeing 787 and the Airbus A380. Nickel Inconel is ideal for the materials for the combustion chamber of a plane. The combustion chamber is where air is sprayed with fuel, then ignited, and then finally burnt. The perfect metal is needed here since temperatures can reach 1800 degrees Celsius. Inconel is special due to its ability to form a thick oxide layer when heated to protect it from further attack, helping it retain more strength over a longer period of extreme temperatures. Steel in such case would begin to form imperfections in its surface, which would diminish its strength. Fires have caused about 20% of all aircraft carrier accidents. Halogens, which are any of the elements found in Group 17 in the periodic table, can be found in things like cushions and cables. However, it has been found that using halogen-containing materials for the interior of a plane is a terrible idea, because not only does it corrode materials inside of a plane, it can also release toxic fumes like hydrogen fluoride, which causes respiratory irritation. Polyphosphazines, a rubber embedded with phosphorus and nitrogen bonds, is actually the best for things like aircraft seat cushions because it has a low fuel value and low heat release. These special rubbers are very expensive though, so we are still looking for a very similar material with a lower price tag. Retake the game now that you understand why carbon composite materials are far superior to aluminum alloys. In addition to, now that you have learned how flexible carbon composite materials also suit the needs of the airplane's wings instead of steel, and why nickel Inconel is one of the best metal alloys that suits the needs of the combustion chamber of a plane.